Hello.
Yes, sir.
Yeah, sorry for both joining late.
It's okay, sir.
Alright. Anubhav Garg. Alright, so this
Yes,
is
sir.
a DSA mock interview. Okay, alright. Okay. Just give me a moment. Let me open this.
Okay, sir.
Okay, so let's begin. So I'm Talchin. Let me first introduce myself. Okay. So I have around 4.5 years of experience into full stack web development. I have worked with technologies like Angular, React, JavaScript, Java, Spring Boot, and Node.js. That's pretty much about me. You can introduce yourself now.
Okay, so sir, my full name is Abhinav Garg and I am from Thapa Institute of Engineering and Technology. I am in my final year and I am in electronics, but I'm into coding from first year itself. I have solved more than 500 questions in various platforms like GFG and LeetCode. I have also done two projects on Python named Real-Time Database, Face Management System, and Invisibility Cloud. So yeah, that's about me.
All right. Okay, so which technologies have you worked with? Python, facial recognition. Okay.
Pa-
hmm
yes.
Okay, so okay. For DSA, which topics you want to be mock interviewed on? All the topics covered, including trees and graphs, or any particular topics in mind?
Actually, I am weak in graphs, so if there is possible कि graph को हम ना करें, तो it would be
Okay.
better.
So apart from graph, everything is fine. Even DP or DP also you should keep aside.
Actually, I am preparing for Paytm-like companies, like who ask medium level questions.
Medium level questions. All right.
So
All right then.
yeah,
Okay. Let's do with trees. Let's begin with trees then. Okay. So okay, let's do
yeah.
this. You know a binary search tree, right? Okay.
Yes, sir.
So what you have to do is write a function that takes in head pointer of the tree and returns if a tree is BST or not. Have you done this previously?
Okay. Yes, sir. I think 6 months back I took that
Your voice is breaking. I think
something
there
of
is
that.
some network bandwidth issue. Hello?
Yes, sir.
Your voice is breaking a lot. Maybe you can turn off your
Yeah.
video to save your bandwidth.
Okay. Okay, sir. Is it okay right now?
Yeah, it is a lot better now. Okay, you can start sharing your screen. Have you done this previously, or you want to try again, or try some other question?
Yes, sir. 6 months back.
6 months back, I think then it should
Yes,
be fine.
sir.
You can,
As you think.
yeah. Let's do this. Okay, you can
Okay, sir.
you can start sharing your screen and start with the approach. How you're thinking about the solution.
Okay, sir. So I have a tree and I have to check whether it is a BST or not. What I know about BST is all the right elements, all the right childs are bigger than the node and left child are smaller than the node.
Mhm.
And for every subtree, it should follow that. So, so for type of tree, it can go maximum to its
Your
minimum.
voice is
It can go
breaking up
to
again. Are you on hotspot?
actually I am in my college, so college का net है and it should not.
Mhm. Yeah, go ahead.
So
Give it a try. Okay. Let's do one thing. You can stop
okay,
sharing your screen. I'll ask when to share. You can think about the solution and write the code down.
Okay, okay, sir. So I'm thinking ki child node always maximum up to its parent.
Mm-hmm.
So we can define the range for every node. Like it can go to this only,
Mm-hmm.
right? So yeah, for its head node, it can go up to minus infinity to infinity, and when we go to left, then it can only go to minus infinity to its parent node. Like
Mm-hmm.
it is the limit. Like parent is the limit.
Okay.
And for the right node, the like for the right node, it should be smaller than the. It should be greater than the parent. So smallest limit is parent.
Mm-hmm.
So okay.
Right.
So I will define the range of every node and I will then code it for every like
You
left
will
subtree and right subtree.
recurse it.
So should I code it, sir?
Yeah, go ahead.
Yeah, yeah.
Go
Okay,
ahead.
sir. So okay, sir. So I have a I'm making it just a bool function. It's limit मेरी int maxi root का if root is null then obviously it is a BST. So
Mm-hmm.
mm, if root का data is greater than or equal to many like and
देखो मम्मी देखो नहीं आधा एक घंटा में मैं किने का तो कौन आया और जी उन्होंने होर पे पता दे दिया 500 रुपये दिया होर पे कुछ लिखो 500 रुपये दे दिया अब क्या मैं चेक करूं वो तो कस्टमर ही बनी मनो अब हदी तो यार
shouldn't
किने बोला ही ना है अब देखो मैं पापा के देख बेटा चिकन की नहीं खाओ लो उन सच्चे बदनी आ ना हो पता क्यों मैं लोकड़ी बननी ही होर क्या लिया
hmm.
70 रुपये लिया नहीं क्या बड़ा खाने
Parent and is a PST root का right. So जब हम राइट करें तो इसका जो मिनिमम लिमिट है वो पेरेंट हो जाएगा या so it is root का data and that is maximum. Okay. So yeah, I think that's pretty much okay. And should I write the only code of or I should make the
No,
bool
no.
function
Function is enough. Just the
discrete
function.
function also?
No, 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 not needed. Just the logic for that
Okay,
should
sir.
be enough. Is it done?
Okay. Sir, just a minute.
Okay,
I'm
sure.
just writing it.
गांव में कोई मार दियो
Okay, so should I share my screen?
if it is done, yeah, sure, definitely.
Okay, sir. So I hope my screen is visible and this is my SBST function and
Okay.
it is taking the head node and the minimum element and maximum element. I'm
Okay.
checking for current, like current node I'm standing on. If it is greater than many, which I need, so I will return true. Like if this is greater than many and less than maxi, then it should be true, right?
Mm-hmm.
And I will check now for left subtree and right subtree, because for every node it should true, like it should return true. So I'm checking here for left subtree and I am checking here for right subtree. While
Okay.
checking for left subtree, like for the minimum element is of parents, like
Mm-hmm.
because they are on the left, and its maximum limit should be its parent. So maxi की जगह पे I am returning root का data.
Okay.
And similarly for right tree. So yeah, that's pretty much my answer. And
Okay. So what will be the time and space complexity for this?
okay, so eventually I am visiting all the nodes, because I am checking for all the nodes. So I
Hmm.
think the time complexity will be O of n.
And space?
and and for space, like
Space complexity.
I think it is it is of one, as we are not using any extra, but it has a stack, like stack complexity, recursive stack.
Mm-hmm. It creates a
And
stack, so that would be of n if we consider recursion stack. Yeah, true.
yeah, yeah, and that would be O of n.
Perfect. Okay, let's go ahead with the next problem. Okay, I'm pasting a link to the question. Maybe you
Okay,
can
sir.
open it, and if you had already done it, maybe you can remove the solution and restart.
Okay, sir. Should I do it on online compiler or like on
Online
LinkedIn
compiler
or
should
lead
be fine.
code
Online compiler, lead
itself?
code is fine. Anything is fine.
Oh,
I would say lead code would be better. We can run and see.
okay, sir.
We can check out the hidden test cases also.
Yeah. Okay.
Yeah, this you haven't done previously, so yeah, fine.
Okay. I have gained one up one. Okay.
Let me know if you don't get the question.
Yeah, I am getting k. I have to find the maximum element for every k elements in the nums, right?
Right.
And yeah. So yeah, like
Mm-hmm.
I can create a subarray
Hmm.
of k size at any element, at every element.
Okay.
So for first element, like I goes to 0 to n, and then j goes to 0 to matlab I to k.
Hmm. Okay.
So I can use two loops here
Mm-hmm.
to find the, you know, maximum element, but it will obviously the increase the time complexity.
Correct.
So I'm thinking if I can, optimize this.
Mm-hmm.
Thinking if I can use you in this because we have to insert element from back.
Okay.
I'm
So
just try running and checking if my logic is correct or not.
okay.
I can use here deck because
You can use.
when I'm dry running, I have to like pop out element from back also.
Okay.
Sir, I can use deck like DQ
Okay.
because I have to pop out elements from back too.
Okay. You'll use DQ, and how will
Okay,
that save us time? We still have to find the maximum out of that deck,
because
right?
sir, yeah, yeah,
So that's
but
still again O of n square.
automatically that maximum element will come.
Okay. Do you
No,
mean
sir, it take O of n, O of one, O of n, sorry, O of n.
O of n for?
Like time complexity will be O of n and space complexity will be O of k.
Mm-hmm. Do you mean Q with heaps
Okay, sir,
like
yes,
min
sir.
heap and max heap?
No, sir, no, sir.
Mm-hmm.
I can think like उस तरीके से भी, but deck will be more suitable, which I can think of right now.
Can you give me a drive run of the input and how you will
And
generate
it
the
should
output?
be, yeah, sure, sir. Like I have, I have this as input, and I'm using DQ.
Your voice
इसके अंदर
is
पीछे से एलिमेंट है और आगे से
your
ओके
voice is breaking again, Abhinav.
सर क्लियर
Sorry,
it is because of
your voice is breaking.
should
Maybe
I stop sharing and
yeah, yeah. Please do that. Yeah.
so like I have sir, I am writing on chat box.
Okay.
Okay, so I have this array.
Hmm.
This sir, there is lot of background noise from your side. Can you decrease?
Okay, just a moment.
Okay,
Just a
sir.
moment.
Okay, sir.
Better now?
Yes, sir. Okay, so I use deck and I insert like k elements, like first k elements. But when I'm inserting, I will only like store useful elements. The useful elements, according to me, is are those which are
Mm-hmm.
bigger. Like, how can I make you understand if there is something like uh, DQ for first के elements, it will be like पहले 1 जाएगा, फिर
Mm-hmm.
हमने देखा कि 3 है इसमें, तो
Mm-hmm.
we know that 3 is bigger than 1,
Mm-hmm.
and at a next iteration we gonna remove the 1. So because it is useless, like because 3 is bigger than 1, so we can pop out 1 from DQ, so it will be
Mm-hmm.
3, right?
Okay.
And minus 1 can is not bigger in this K, but it can be bigger in like next iteration, so we have to keep it, right? And
Okay.
now we have iterated for first K elements. We have 3 and minus 1 in DQ, and now we will like store the maximum first front element from this DQ. So 3 is our first, so we can write 3 is the greatest in the like K
First window.
size subarray.
Okay.
Now we will move next iteration. Yeah,
Okay.
now I will be pointing to minus 3.
Mm-hmm.
We will insert minus 3 into DQ from back. Like, okay, I have inserted.
Okay.
Still, 3 is the biggest. So 3 again I will put into my vector answer.
Mm-hmm.
Now I will point to 5.
Mm-hmm.
But f- like before putting 5 into my DQ, we have to remove the like I minus kth element, because only we have to create the window of k size, right?
Mm-hmm.
So instead of storing elements, I will store the index in DQ. So I will remove 3 if it is equal to I minus k. Like I will check
Mm-hmm.
if front element is equal to I minus k, so I will remove it.
Okay.
Now
One question.
here comes 5, but we, yes sir,
So you are saying that you will find the maximum from k size window, right? So what is the complexity of that?
yes sir.
That's again of
Sir,
n, right?
L of n, yes, 10 complexity.
Basically k, O of k for the finding the maximum from the dq, your dq. So it's gonna be again O of n into k.
K is complexity.
So k can at most be n also. Basically it's n square. It's nowhere higher highly efficient than our brute force approach, right? Getting it? It's still O of n square.
Okay,
Got
yes,
it?
yes. Like, yes, it is n and k. Okay. Right.
So can you think of any optimization? Maybe n log n. And log n would be our better solution, right? Maybe in that
Mm,
way, if you can think.
log n, log n.
And
So
log n basically.
we can do it like priority queue, because
Mm-hmm.
okay, I can think of priority queue
Okay.
also instead of DQ.
Mm-hmm.
Like,
I think DQ is same
can
as
I spell it
priority
for
queue
you?
in C++, right? Isn't it? But you have to use it right, properly.
Yes. Okay. But sir, priority queue will also give like analog k.
But in it is better than n square, right?
Okay. Okay.
I haven't come across DQ, so I think DQ is same as priority queue, or no, it's just a queue.
I think sir, it will be.
Okay, I think you're going right. Okay, DQ, but Finding the maximum element is our challenging part right now, because what would be the logic if let's go with your approach. Okay, you are creating this window, you are putting those elements in
Okay.
the DQ. So how will you find the maximum element? You will iterate over the k
Yes,
elements
sir.
and find out, or you would use some kind of
No,
optimization
no, no.
there.
Like,
Mm-hmm.
no, sir. जैसे अब मुझे like I5 को point कर रहा है, so
Okay.
I have to add 5 in my DQ, right?
Okay.
But we see कि 5 is greater than the previous like
Mm-hmm.
back element of DQ minus 3. So
Okay.
we can just pop out minus 3
Okay.
because it is useless. It will shadow 5 will shadow minus 3. And for minus 1 also 5 will shadow minus 1.
One question.
So
If you
now it is empty or
Mhm.
like
Okay, okay. Go ahead.
okay, sir.
Go ahead. Go ahead. Go ahead.
Yes, sir.
Go ahead. Go ahead.
Okay, if it is now like a smaller element or empty, so now we can enter 5. Now
Mhm.
after the iteration, like at the last step of iteration, we will just see which element is present in front of TQ. It is 5, so we can insert 5.
Ah, right, right. In that
So
case, this is
4
of
minus 5
n
is
only,
still
right?
5.
In total, yeah.
5 is not.
Perfect, perfect. That seems perfect solution, man.
Yes,
I
sir.
was assuming it different, and I thought it would be n square, but yeah, finding the maximum is taking only constant space in this, right? Yeah, I think that would work.
Yes, sir.
All right, you can start coding it out.
Yes, sir.
Perfect, man.
Okay, sir. Like, so I'm just creating a DQ. Okay, so like for IK. Okay. Now I is this. If And okay, so if like I here and K 1 2 3 K, so remove this. Okay, now again LTK is not empty and here I'm safari to pop 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 and then I will insert it. Okay. And now here for every element I have to push I. So yeah, now I contain I for every element and I can put into answer that is nuns of dq dot find answer. It should work. Dq. Sir, it is giving something syntax error.
That should be fine. Okay, you can start sharing your screen. Let's have a look at it.
Okay, sir. It is visible, sir.
Yes, it is.
Like
Hmm.
I just forgot कि पिछले रियर कहते हैं या फिर like back front back नहीं back. Otherwise it should work completely fine.
So just explain me the approach, no?
Okay, sir. So I for first k elements I have to only first store in DQ,
Hmm.
right? So if my current element which I am gonna insert in my DQ is bigger than the like back element of DQ, then I have to pop out the back element so that because it is shadowing that DQ elements.
Hmm.
So I am doing here, and
Okay.
after when I becomes equal to k, then I will okay front element हमारा सबसे बड़ा element है.
Okay.
तो as I am storing the indexes I will like call the which index it has, so I will store that. अब if that element is present in DQ, like first k elements are present, now we are on next iteration, but still we are seeing okay from the previous iteration first element is also present, then we have to pop it out, right?
Hmm.
So I have used this function
Pop front.
to
Okay.
pop it out for every iteration if it is there.
Okay.
Okay, so now I have to insert the current element index. So for this I am using this approach like removing the small element because it is obviously a shadow.
Hmm.
So now after removing the small elements I will put index into my DQ
Hmm.
stack. Then I will check okay this is the first element of our DQ and that is gonna be the largest, so we will put into our answer. So
Okay. Yeah.
this is my logic.
Yeah, that should be fine. What is the time and space complexity?
Sir, because like our deck queue can maximum only hold k elements. So
Hmm.
I can say k is the space complexity if I am not considering the answer complexity, space complexity. So
Hmm.
k is my space complexity,
Okay.
and for time complexity, it will be n into k.
Actually, it will be n only because at most you will take only n times, right? So one element once. So it will be n itself.
Okay.
It won't
Yeah.
loop over k
Yeah, right,
times.
sir.
Every element k
And
times we won't do. At most once will go. So it is off n itself actually. Okay.
yeah.
All right. Let's get to the next
Okay,
part.
sir.
One last question.
Okay, sir.
I've sent you in the chat. If you can open it.
Okay. Okay. Like,
Sorry.
but obviously, it will increase the space and time complexity.
Mhm.
The second thing is sir, I had think of a solution in which I will merge the both arrays, and I will then find the like median.
Okay. So what will be the time complexity to merge two arrays?
So okay, time complexity will be like for that it will be like n plus m for merging the array,
Hmm. And then you
and
have to
for
sort
sort
it.
it,
Hmm.
yeah. So it will go like n plus m log n plus m.
Right. So do you think there would be any optimal solution than this? Can you think of that?
I'm just analyzing it. basically have to move the like mid element, right? I will calculate this as, let's say it will be n plus m. Then I plus j should get less than okay, like 1 3 ij. Okay, 1 2 j size is 4. So, sir,
Yes.
I can think of
Mhm.
like
Go ahead.
median is what? Median is like middle element, and
Right.
I know how I like merge two sorted arrays.
Mm-hmm.
I will point I to nums1 starting from 0, and similarly for j. Like when I plus j will equal to size upon 2, here my size means nums1 का size plus nums2 का size.
Mm-hmm.
Then it will be my median. I plus j, I will move it like by using like whose element is like small. I have to move that. Basically concept of merge two sorted arrays.
Okay, so nums one
I
size,
think
nums two size. First, you will point to first element of each, and you will go forward until you
yes sir.
get by two size, half of the size of total. Is that right?
Yes sir. Yes sir.
Hmm. Seems of n complexity, basically of minimum of m comma n, right?
Sir, it will be n plus m complexity.
Mm-hmm. M plus n, it won't be, because at most you will visit m plus n by 2. Yeah, m plus n, correct. Okay. Do you think there is optimized solution than this?
Yeah, I think there should be.
Hmm. Yeah, this is fine. M plus n is fine, almost. But there is also a solution with log of m plus n.
Okay.
So that's an interesting thing you can watch
Yeah.
about. I think we are almost time. I only have 5 more minutes for you. So
Okay
let's
sir.
get back to the feedback part. So okay, everything seemed fine. You're able to solve almost three problems. So your problem solving skills are good. You can clearly clear all the interviews that you can give. But one request I have for you is speak out
Yes
loud
sir.
more. You can't just directly go to step one to step two. Okay, you have to speak about how you're going from step one to step two, from step two to step three, how
Okay.
you're going, that you have to describe it more. Okay, that's the one thing
Okay.
I think you have to improve on. Other than that, everything else is good. You are really good in problem solving. Okay.
Thank you sir. Okay
Yeah.
sir.
Do you have any questions?
No sir. Everything is clear.
All right then,
Sir,
thanks man, all the
yeah,
best. Yeah,
actually there is.
yeah, go ahead, tell me.
सर जैसे I am solving the question, should I tell the how, why I'm writing the this line, why I'm writing that variable to the interviewer, or
No, I mean that, let's say, take an example of this sorted algorithm that we are talking about, right? So, what was the
okay,
first thing that came into mind? What could be the solution? You have to talk about that. So, first, you are thinking about merge sort. You could say, like, I think merge sort algorithm can be used here. I think I can merge the, as I already have two sorted arrays, maybe I can sort in a way that it could be more efficient and I need to visit only m plus n by 2 size. So how you are going from step 1 to step 2, that is more important. You don't have to explain each code you line code, basically the
okay,
line that you write, but the approach, I mean, in the beginning we discuss about the approach, right? Once it is fine, then only you get into coding. In coding you don't have to speak much. Interviewer is only
okay,
interested in the approach, how you are approaching the problem, how you are trying to solve it. Okay, getting it?
okay, yes sir,
That is the main part. Okay.
okay sir,
I can give you another example. Like we were doing in the previous example, the sliding window, right? First, initially, we give a brute force approach. Then we'll say that it is always a window of size k. So maybe we can optimize this somehow. So what could be the best algorithm that we use is maybe with the help of a queue, I can remove the oldest element because we need only size k. So q would be most efficient here, so I would like to use q. So in q again, how would you optimize it so that it will only contain the maximum element which is needed? Then you can explain about the logic that you came up. So exactly what's happening in your mind, that you should speak out. That is the part. Okay,
okay,
got it?
okay, yes sir,
All right, anything else?
no sir,
All right, thanks man, all the best, keep on practicing.
thank you
Okay,
sir,
bye.
okay sir.